Today I'm going to look at that SLVR5 that I showed you a couple weeks back. I've got the part for it today. We're going to put that gear in and see what else it might need. So stripping the machine down, get to the mechanism on the bottom. These ones are relatively easy to change the blue gear on, unlike the SLVR1000, which was a little more involved. These ones here are actually quite easy to get to. Now I suspect there probably is going to be other problems with this machine besides that. Hopefully nothing too serious, because I'd really like to get this machine, that needs to be lubricated. See, that's kind of gummed up a bit. So we'll lubricate the P6 guide as well. But first things first, we'll get the bottom off. I picked this unit up at the same time as I got that SVO 2000. If you guys remember the last one I worked on, I had changed a whole bunch of capacitors in the power supply. I changed a whole bunch of caps in the audio hi-fi, and I even did the IF and the tuner. I won't be doing the same on this one, obviously, because nobody's going to be tuning anything in. And a machine like this will just be one that I sell for people to archive with. So I'm more concerned with how is it going to play back. But I will change caps that are bad. If I determine there are any that are bad, causing issues, they will be swapped out. But first things first, before I even get to that, I have to replace the blue gear. And on this type of chassis, this one's actually really simple to get to. And it's getting a little bit chilly in here, so I think I'll turn on the heat. It's down to like 3 degrees in the shop. Right now it's sitting just above 0 outside. Doesn't look like this has ever been worked on before, which is good. As I say, these ones are, maybe help if I turn on some lights so I can see what I'm doing. These ones are a little simpler than the 1000, because on the 1000, you remember, because I've done a number of them, where you actually have to remove the chassis. Well, not so on this one. This one you just simply unplug the connector that's going to the drum motor. Take out the screws, and then just lift the board out. Make sure I got all the screws out. All the arrow mark screws are out, and this should just lift up now. Everything unplugs, and the board will just lift up. I should be able to lift these connectors out enough. There should be enough slack on here that I can lift this up and just turn the board up out of the way. Oh, I forgot that plug. Should have pulled the front basket out. Anyway, I'll have to deal with that one later. Get that one back in, but the board can just lie flat like that for now. I forgot about this connector on the side here. Should be enough slack to plug that back in. We're wondering where the other end of that cable goes. It's the front loading. You got to undo that connector there, otherwise it will pop out. So now I can get the slack back a bit and plug this one back in. And I don't need to take out any more than this. I can work on it right like this, because this is the area I got to work on. I got to change this broken gear. So to do that, I need to take off the 3 cut washers, remove the main cam, and then remove that cut washer, remove that cut washer, and that one will move this gear. And then I can swap them out. Also going to clean the mode switch, obviously, and we notice that the timing marks here, this is in the home position. So we'll see that the timing marks are lining up. right now before I touch anything. Got that little arrow pointing at that little mark there. There's a hole, you can see through the chassis there. This is in the home position, and you can see this pin right through that slot there. You'll see another hole here that looks right down through the chassis, showing that everything is in the correct timing state before I start. So first things first, let's remove the cut washers. They just lift off quite easily. And then I can remove this gear, or this top piece off the gear, the retainer. Now I can lift the gear up, and I can just pull it straight up like that, set it out of the way. Doesn't appear to be anything broken on that, just set that out of the way for now, and push the gears up out of the way. We got to take off this cut washer, which means the guide is going to fall out. I'm going to put the guide back on later. We'll take that one off, something to lift it with. Now I can lift this cut washer off, lift off the broken gear and the control arm. Okay, that's the piece that I have to put the new gear on. Turn it, take it off just like that. Take off the spring, drop the spring into the new gear, kind of goes in like that. Then we're going to bring the new gear, and we've got to hook that end of the spring here around this catch. So I'm going to bring the guide into place like this, so I can hook that catch under there. You see, now it's going to hook the catch, and then I'm going to turn until it locks back into place. And that's it. That's how simple it is to put that gear on. Now I just need to reassemble everything, and that's done by setting the timing marks. This gear goes under this one. So the easiest way to do it is we lift this gear up out of the way so that I can slip this gear on under it. These are the timing marks here. There's one hole or one cutaway there, and this hole here. They line up. That'll give us our preliminary timing. So we just put the gear in place like that and line it up. That's now in position. And when we rotate the guide back, when we bring it down, I can grab the guide that needs to go back onto here, put the cut washer on. To do that, I got to stand it on end so I can hold the guide in place and then throw the cut washer on. So I've got my arm underneath to hold the guide in place so that I can place the cut washer on and lock it on. Like that. Okay, now my cut washer's in place. I can lower the chassis down again, and you'll see that the guides now are timed. So they reach the top of their travel at the same point in time, you notice? When I do that, I have to bring this other guide in. I have to pull the tension arm in. And we see that both guides go down to the basement, all the way down. And there should be a timing mark right here as well. Right on this, when they're in the unloaded position, there are a couple of arrows. You'll see them right here. Right? You got one arrow there and one arrow there. So when they're down, those arrows are pointing at each other, and there's no way to adjust that any more than that. I think that's it right there. Okay? Arrows are pointing at each other. So now when I go all the way to the loaded position, you'll actually find that these ones are not lined up, but that gets you close. But now when I adjust it, you'll see that both guides hit the top of their travel at the same time. And now we're completely unloaded. Now I can go and put the main cam gear back on. When I adjust the main cam here, remember I haven't moved any of these others, so they all should be in the correct position. We can verify that by looking at the alignment holes to make sure that the alignment holes are all lining up, which they are because I haven't changed anything. Make sure that this is down, and all these holes, you'll see there's an alignment hole through there, which indicates that that's the wrong position there. That's the correct position, because the alignment hole, I can put the screwdriver down through. Put the screwdriver down through that one. That alignment is correct as well. So now we know everything is correct. Hold this in the unloaded position. Drop the main cam on. And remember, we're going to see this piece right through here. Just rotate it slightly until everything locks in, and then just give the whole mechanism a slight little nudge just to make sure that it locks into place like that. Okay, now the main cam is in place. I can put the retainer back on. It goes on that way. You know which way it goes on because you can see the wear marks on the other side. So it goes on just like that. And now we've got our cut washers that hold this in place. Actually, these ones aren't cut washers, these are full washers. These are retainers. Okay, now that the mechanism is back in place, we can proceed to clean the mode switch because it's going to need it. Remember that the alignment is all correct. You can see the holes are lining up. So nothing has shifted. You can still see the timing is correct. To clean these mode switches, it's real easy. Loosen off the screw. You don't have to take it off, just enough to get some slack in the belt. So you can remove the belt out of the way. It's a tooth belt, so they never wear out, pretty much, ever. I've never actually ever seen one wear out or break. It's a nylon belt. 2 screws. The black one goes on the top side here, or the one facing towards the back, I should say. Top on your screen. Lift out the mode switch. This is going to shift slightly. Remember to pull that back into place. And we're going to pop the mode switch apart. Just squeeze the little tabs and it'll pop apart and reveal that it is dirty as hell. So let's get some cleaner. For this, I'm just going to use good old Neutral. This is the old formulation of Neutral, which is a little better than the newer stuff. We'll spray some on the switch. And then using cotton bud, just polish up the contacts. You can see the crap that's coming off the switch right away. Yummy! We'll use the other side of the Q-tip to saturate it with cleaner and just use this to clean the actual switch contacts themselves. And they are also dirty. And of course we'll clean the contacts that connect it to the rest of the circuit because they are also oxidated quite badly. Give another shot of Neutral. There's just a little bit to leave on the switch itself to keep the contacts clean. Then we'll put the switch back together and rotate it multiple times for the polishing action. Alright, now that it's clean, we can rotate to find our timing mark. There's our timing mark right there, pointing at this gear, and we're going to just move this little lever back and forth here just to mesh it in, and it'll drop in place just like that. And then the 2 screws. Now people have asked me before, what is the purpose of this spring? it serves no purpose, right? Well, it only really serves one purpose, and that's when you put the belt on. It keeps the belt at the correct tension, and then you tighten down the screw. Once the screw is locked in place, this is not moving. So the spring is kind of redundant. It doesn't really do anything at all because it's anchored to a plastic, just the chassis tab, and to this metal bracket. But what it does is it sets the initial tension so that the toothed belt is at the correct tension. Too loose and it could slip, too tight and it'll provide excess torque on the bearing of the capstan motor, which could cause it to warp and start to rub on this side. So that's what that is there for. Okay, now I can turn over the servo board, line up the plugs, press it back into place, plugs into the capstan motor and the mode switch. Cut myself in the process. I drew blood. Put the screws back in to hold the board in place. Looks like we're going to get our first snowfall of the season today. They're calling for a dump of snow, which will add more to the anxiety of having to drive a good distance tomorrow to take the cat to the vet, because it's a long way and it's going to be a lot of snow, a lot more snow there. I forgot about this little ground tab here. We'll bring that out. Goes on this side. So it'll be a white knuckle drive tomorrow because I have to go all the way to Langley. Alright, unit's ready to turn over and test it. Plug back in the loading motor. I won't bother with this guy just yet. Looks like somebody's had this off because they put red paint on there. So somebody's had that part off before and they've serviced that. But I want to see if this thing loads in place. That's the whole purpose, is to make this thing run. So monitor out. Monitor out and line out are two different outputs. One of them has the on-screen graphics and the other one does not. This one's got the on-screen graphics. Power the unit up and find a tape. Okay, turn the machine on. I have a blue screen. Moment of truth. Is it going to load? Of course it's going to load. Is it going to play? I think the tape's at the end. Let's just rewind the tape. Is the tape going to play? It is going to play, but it's not going to play very well because we have capacitor problems on this unit now. That's the classic symptom of bad caps, is a picture that looks like that. Tracking, but we have bad caps. This is going to be power supply, so let's deal with that next. So first I'll remove the tape. And next we'll remove power and then remove the power supply at the back here. Nice thing about these units is that the power supply is modular, so it comes out relatively easily. Just pop out a couple screws. and drop them inside the unit. And the power supply will just lift out, and then I'll unplug. 2 plugs. Okay, first things first, pop the bottom cover off. Oh, someone's been in here before. Look at that, someone's been changing caps in here. Well, obviously they're bad again. That explains why the wrong screws are in here, they're the wrong color. So let's get the ESR meter out and see which ones are in rough shape. So what I found is all these caps have been replaced on here, but there's one that was replaced with an 85 degree, and it's this one right down here. And well, you can't use 85 degree caps in switching power supplies. So let's just pull that one, because I bet you it's open. I've been going through with the ESR meter, and everything is, like, they all look good so far, the ones that I've tested. Except this one that's an 85 degree cap, which you say should never be put in where you require 105 degree. They're just going to fail again. This board is in such bad shape, I'm scared to touch it. Now, all these boards are in bad shape because the problem with these ones was this was made in the Elna era, where they used a bunch of Elna caps and they all leaked. And they corroded on the board. And I mean, they were just horrible. And I've repaired my share of them over the years. The one that I've got has had the board repaired like this on it too. I repaired it the second time when it became mine. Pull that one out and just check it. Let's see what it looks like. I'm sure it's open. That's 2 ohms. 1.8. It's 1 microfarad at 100 volts. So I mean, it's measuring within spec. Spec shows 18. It's measuring 2. So even though it isn't a high temp cap, it's not measuring bad. So I don't think that's what's causing the problem with the picture. I am going to put that original back in, even though it's only an 85 degree cap, because that's not going to be what's causing the problem. That cap is going to be in the negative supply for the vacuum fluorescent display. That's what that one's for. So the display is working. So I'll put that one back in. Because that's not causing the picture problem. It could be a couple of these ones over here. These ones don't look like they've ever been changed. These ones over here, and this one here kind of looks like it's been expanded a bit. If you look at the edge of it, so I'm going to check these ones because these look like they're originals, that they were never changed out, and they do cause problems. So let's just pull these ones and check C215. As you can see, there's crap leaking out of the bottom of this one. So I'm sure that this one is bad, as are its neighbors. and the fact that they haven't been changed is a pretty good indicator that they're probably no good. 0.3 is what it measures. Now this one here is a 330 at 25 volts, and a 330 at 25 volts should not be any worse than 0.12 if we look at the meter here, right? So between a 220 and a 470 point at 25 volts, between 0.12 and 0.23. If we look at this one, if I zero the meter out, make sure it's at 0, we are measuring 0.5. So I think this one's shot. This one's got to go. So that one's going to get replaced with a new high temperature cap, 330 at 25 volts. I think these are all the same. 330 at 25, 330 at 25, and I think this one's the same as well. But we'll change out these ones. See how this one looks. Another 330 at 25 volts. Let's see what shape this one's in. .8. I think this one's also 0.3. I guess it's a little bit better this time. Maybe better connection on it. This one doesn't look to be dried out as much as the other one, but it's also a 0.2. So yeah, this one's probably okay. This is between 0.18 and 0.33, so this one's likely okay. So we'll put this one back in. Just change the one that's actually bad. This one. Check this condition of this one. .27. So it's between, it's like right on that edge, but I think we're probably okay on this one. If we look at the one that was bad, you know, it's like 0.34, 39. See, this is the one that was out of spec. So 0.27 is kind of, it's in between. But this other one is certainly bad. We'll try it with the original one in here. Because this one doesn't have any indication that there's anything leaking out of this one. Yeah, let's just try this one. I'll put this power supply back in and just see if changing that one cap has made an improvement. So I forgot one thing. I gotta run this on something other than a plasma because I've got all the shielding off, so that bloody plasma is going to interfere with it. So I got the LCD monitor hooked up. Let's see whether this one plays back any better.
To give them the
and
home theater
indeed, it
experience
fixed
of
it.
an elegant and easy to use
Nice
Bose
dropout
lifestyle
split.
system.
There we go.
Good luck.
It's playing.
Thank you.
Lots of dropouts on the tape. Let's try some other tapes. Here's a pre-recorded tape. Obviously, I can't show this for more than a few seconds. Here's another one. I can play this one because...
And when to say no. Buying a car is a game between the buyer.
Lots of dropouts on these tapes. These tapes are old. That's what's causing the white lines, is dropouts. But as you can see, it's playing, which is good. Now I can turn around and sell this machine because I really don't have any need for yet another machine. But there we go. One capacitor in the power supply was bad. Got to clean the heads on this. I'm going to do that P6 adjustment as well, lubricate that bearing. But yeah, lots of dropouts. Let's try a different tape again. So here's another tape playing. This one seems to be also playing okay. Yeah, we'll check, as I'll check the preamp. Check the caps in the preamp. They have been known to cause problems too, so we'll check those out while I've got it here and renew any ones that are bad. So let me just pop the preamp out and we'll take a look at that. This is the RF preamp for the video head and hi-fi heads, and there will be guaranteed some bad caps in there, guaranteed, and we're going to change them because they have to be changed. They will affect the picture quality dramatically. So I'm just waiting for my soldering iron to warm up so I can remove the grounds, and then we'll pull the board out. I've already taken the front cover off of it, right? This thing sits together like this, like the shell in here, right? But I've taken that off. I got to unsolder these points now to get at this, but there are some surface mounted caps on this one that will definitely be bad. Probably some regular caps too, because this unit is quite old and these are the type that cause a lot of problems. Oh yeah, yum, look at this one. So as you can see, there are a couple surface mounted ones on here. This one's leaking too, but let's change out these leaking caps and then we'll check the picture. You can see where it's been leaking on the board too. This one here is blown right open. It's leaked everything out of it. Should clean up the board here too, where this is leaked onto the board. Get my toothbrush out and some isopropyl. Clean up the board a bit. There's another Elna. This is a 10 volt 220. I'll find one of those and we'll replace that one. Okay, that one for sure. And we'll check some of the other ones on here as well. I'm sure this other little surface mounted one over here is going to be the next one that needs to be done. I don't think they'll all need to be changed, but we'll check them anyway. But for sure the ones that are bad are going to have to be done, and this meter looks like this is going to break pretty quick. I'm going to have to redo the lead on here pretty soon, as it looks like it's ready to break right off. The black lead here on my meter, it's just hanging on by a thread. That one is open. Okay, that one's completely open, so we kind of expected that the surface mounted would be bad. Surprise, surprise. The through hole ones are probably okay, except for the one that was leaking. Like these ones here look to be okay. That one could be bad. What is that one rated at? This one is a, oh, it's a 0.1. No, we'll be fine. A 0.1, yeah, that's okay. Now there's probably okay. How about over here? That was probably okay. Six ohms. What is that? That's a 1 microfarad. That's probably okay as well, because they generally are fairly high ESR. How about this one here? 2.7. That's probably also okay. I checked that one. This one here is 1 ohm. I think that's probably okay. How about this one over here? 3.2, 10 microfarad. Yeah, we're good. We're good on that. Same with this one over here. Okay, so this one here's got to go. This is a 22 at 6 volts. We'll change that one. And then I'll try it and see how it works. I'm going to try it with those two swapped out. Of course, the name of the game is to change as few caps as possible. Someone's going to thumb this down. But these units don't go for a lot of money. Contrary to what people think, that these Super VHS machines are worth hundreds of dollars, they're not. They don't go for very much. I'd be lucky to get $50 or $60 for it, believe it or not. I say I'd be lucky to get that, so we're not gonna go too far as replacing every part in the unit that could possibly fail, because there's no even any guarantee that I'll ever sell this thing. I've got a number of working VHS machines on the market right now for $25, and nobody wants them. They just don't sell. A beta machine will actually get a bit more money because they're a little more scarce. But yeah, these machines just don't have any real value. The only people that are interested in equipment like this is someone who's got some tapes and they've had a machine that broke and they want to archive tapes. And that's really the only market, because people don't record stuff on tape anymore. Contrary to what some of the comments that I read on my channel, people saying how much they love tape. The reality is, people don't use tape. The only thing that people use old VHS machines for is playing back existing tapes. It's the same with that SLHF1000 that I worked on last week. The only reason that one was being repaired was because the guy that owned it has a bunch of beta tapes that he wants to digitize. That's the reason it was repaired. Other than that, it wouldn't have been repaired. And that's pretty much it with these machines as well. These Super VHS machines. The only reason why somebody wants a Super VHS machine is that they've got tapes recorded in Super VHS that they want to be able to play back. It's not that people are recording stuff in Super VHS anymore. If they are, they shouldn't be. So I think this one's looking pretty good now. I think we're going to call this one a day and be done with it. Before I finish up, I'm going to lubricate that P6 guide, because those were always a source of problems, even though this one's not problematic right now. This is a source of trouble. So to do that, I'm going to remove the guide. You can use a little nut driver if you've got one, or just a pair of pliers to back off the nut. Now this is a locking type nut, so it will hold it in place. You don't need to put any paint or anything on it. It's like an aircraft type nut. It's got a Teflon washer built in to lock it in place. Real common failure on these is this guide gets gummed up and it freezes, and then it usually will break this gear down here. So we're gonna just lift it up like that. Take the washer off the top. Just put it back on. We're gonna clean this post and clean the inside of the gear, or the bearing itself. And we can use Molly coat or oil or whatever to lubricate it. Molly coat works good, Super Lube works good. We're just going to clean off this bearing, and we're also going to clean the inside of the guide bearing, and do that by just pulling off the... I typically just use a small screwdriver or something to push cotton through. That way it'll just clean out what's inside that bearing, so that I can put some new lubricant on. Get a little bit of Molly coat, that's what we're going to use on this one. And again, just the smallest quantity. Too much is worse than not enough, as they say. So just the smallest amount. That's probably more than enough onto this post. We're also going to do the capstan. Put the post back on, or the P6 post. Spring locks in behind here to pull it back to its home position, and it'll snap down and lock in place. Like that. Now we have to set the height on this, and how that's done is by running a tape through and watching if the tape curls either way, either towards the top or the bottom as it goes over the pinch roller in forward and reverse. It's best to use a relatively thin tape to do this too, because the thicker tapes tend to not curl quite as easy. So a T120 or a T160 are usually pretty good for doing this test with. So just kind of put that in place. We're going to power the unit up and run a tape through it and see what it does. This time I've got a T160 tape. So what we're going to look for here is we're going to look for any tape curl around in this area here when I forward and reverse, because if the guide is too low or too high, you'll see the tape curling up when I go into search. See? Tape is going down. You see that? So that indicates that the tape is, the guide is too high, so I'm going to turn it down a little bit. And then we're going to try it again. What I'm looking for is I'm looking for any damage on the bottom edge of the tape, any warpage. I see it starting to curl on the bottom edge of the tape there. I don't know if you guys can see it on camera or not, but if we look at the tape right over in here, we'll see that the bottom edge is kind of wrinkling a bit, so that means I'm still a little bit too high. So we can take it down a bit more. And observe it. Go into reverse search and watch for any tape riding up the pinch roller. And I go to reverse search. Okay. Still going down just a little bit when I did that, which indicates now I'm just probably a little bit too low. So now I've got to just bring it up a bit by backing the screw off a bit. Maybe about half a turn. And we'll do it again. And eventually we will get it so that the tape does not move, does not ride up or down when you're in search. And that's what you want. That's how you do the alignment for P6. Another point to lubricate is the pinch roller. We're going to remove this one screw here. Now when you do this, you got to hold the tower gear so that it doesn't change. You don't want to knock your alignment out. So when I do this, I'm going to hold this tower gear down in place while I lift this bracket out, because I don't want it to lift up. I just want to be able to remove the pinch arm. So I'm going to hold that in place, and I'm now going to put some moly coat grease. We'll clean this out as well. Clean the bearing out. Clean off this post. The same lubricant was on there from the factory, and it dries up. When it dries up, it can cause the pinch arm to freeze when it's trying to raise or lower, which can break that little plastic piece right there. It snaps off. So once we've lubricated, or once we've cleaned that, again a little bit of moly coat. Don't need much, just a little bit, onto the pinch arm mounting post, and another little bit onto the gear here, and onto here, onto there. This is actually where this came from. This moly coat grease. When I ordered pinch roller assemblies, when they broke, every one that we ordered, they shipped a package of moly coat grease. This was actually when I ordered them from Mitsubishi, because Mitsubishi used the same design and it had the same failure point. The original black grease all dried up and caused it to break. So this was the repair kit. Came with a pinch roller, arm assembly, and some grease. Hold the cam gear in place so it can't turn or can't jump up, because you only have to worry about it lifting, right? It's not going to go out of alignment this way. You just want to make sure it doesn't lift. And put the top piece back on, and then the screw in place. And that will complete the service on this unit for today. I'll clean the heads on it and then reassemble. Now that it's fixed, I'll run some tapes through it to make sure everything's good. and then this one will go up for sale. There we go. It's playing. I think I can probably show this video without pulling a copyright strike like I can if I put Titanic up. We'd be getting a copyright match immediately. So there it is, it's playing. This one's done, SLVR5. So on this one, what did we do? We replaced a bad cap in the power supply, changed a couple caps in the head preamp, changed out the blue gear, and did the basic lubrication of the areas that need to be lubricated. It's going to clean the heads and throw it together. Thanks for watching. We'll catch you in the next one. Bye.